All right, let's look at the homework 1.5, 1.6, problem number 3. All right, so we have a 400-gallon tank. So we have a tank. All right, so it's a 400-gallon. All right, and initially contains 100-gallon of brine. So you have 100-gallon. All right, so it's 100-gallon. And the brine and containing 50 pounds of salt. So 50 pounds. All right, and a brine containing 1 pound of salt per gallon. So we're pouring in, all right, 1 pound of salt. So 1 pound per gallon, and pouring at the rate of 5 gallons per second. So at 5 gallons per second. All right. Then we're draining it out at the rate of 3 gallons per second. All right. So we are draining it out at 3 gallons per second. All right. So let's set up a differential equation. So we are looking at the rate of change of salt with respect to time. All right. So rate in would be 1 pound per gallon times 5 gallons per second. So it's going to be 1 times 5 pounds per second. All right. Then minus rate out would be, all right, so the concentration here is going to be, so amount of salt at time t is S, and the amount of solution is going to be, all right, so you can see that you're draining at the rate of 3 gallons per second, but you're pouring in at the 5 gallons per second. So the difference is 2 gallons per second. So the amount of solution is increasing by 2 gallons per second. So you start out with 100 gallons, but it is increasing by 2 gallons per second. So we put the 2T. So that will be the concentration. And then it's pouring at the rate of 3 gallons per second. So multiply by 3. All right. Then we have an initial value condition, which is easy to find because S of 0, since you start out with 50 pounds of salt, so S of 0 is equal to 50. All right, so let's solve this first order linear equation. So I'm going to actually rearrange it a little bit, ds over dt. All right, then I'm going to move this over to the other side, so it's going to be a plus 3 over 100 plus 2t s, right? And is equal to, right hand side is 1 times 5, so it's going to be just 5. Right? So integrating factor I is going to be e to the integral 3 over 100 plus 2t with respect to t. Right, so let's see, derivative of 100 plus 2t would be 2. So I'm going to actually rewrite it this way. So I'm going to pull out the 3 here. And then we keep the same denominator, of course. But I would like to have 2. So I'm going to multiply by 2 and then divide by 2. That way we don't change the quantity there. All right, so we can see that this is going to be e to the 3 halves. All right, so this is just going to be a natural log of absolute value. Actually, we don't really need to put an absolute value there. 100 plus 2t. All right, then we can put the 3 halves up here using the log property. And also, e and a natural log cancel out because they're inverses of each other. So you end up getting 100 plus 2t raise it to the 3/2 power. All right. Then we can find S by 1 over I. So I'm going to actually write it as 100 plus 2t raised to the negative 3/2 power, because it's 1 over I. Then integral, q of x is 5, so it's going to be 5 times I is 100 plus 2t raised to the 3/2 power with respect to t. Alright, so let's find the antiderivative. So I'm going to have 100 plus 2t raised to the negative 3/2 power. Alright, then let's see. I'm going to actually pull out the 5. Alright, then the derivative of 100 plus 2t is 2. So I'm going to divide by 2 and multiply by 2. Alright, then we have 100 plus 2t to the 3/2 power with respect to t. Alright, so we can take the antiderivative of that. You will get this. So you have 100 plus 2t to the negative 3/2 power. So 5/2 is just pulled out. Alright, then antiderivative of that would be just add 1 to the power. So 100 2t to the 5/2 power. Divide by 5/2 is the same thing as multiply by 2/5. Right? Then plus some constant c. Actually, I want to do one thing a little bit different there. I'm going to keep this 5/2 inside, right? Because we can cancel those guys out. So here, cancel there, right? Then once you distribute this guy, you get, let's see, 5/2 minus 3/2. So it's going to be just 100 plus 2t. Right, then distribute that. So it's going to be plus c over 100 plus 2t to the 3/2 power. All right, so this is going to be our S of t. All right, to find the c, we have to use the initial value condition. So let's plug in find S of 0, t equals 0. All right, so if you put 0, we're going to get 100 here. So 100 plus c over, right, put 0 there. So you have 100. So square root is 10 and cube it. So you have a 1000. Right, this is supposed to be equal to 50. Right, so we can solve this by subtracting 100. So c over 1000 is equal to negative 50. Right, and then we're going to multiply through by 1000. We get c is equal to negative 50,000. Right, so we got negative 50,000. So therefore, S of t came out to be 100 plus 2t, right, and minus 50,000 divided by quantity 100 plus 2t raised to the 3/2 power. All right. Then we want to know the amount of salt when the tank is full. So we can see that, let's see, we have 300 gallons to go to become full. And it's increasing by 2 gallons per second. So 300 divided by 2, so it's going to take 150 seconds. So when it's full, t is equal to 150 seconds, right? So we just have to find S of 150. And this comes out to be 150 times 2 is 300 plus, so that's going to be 400 minus 50,000 over, all right, so this is going to be 400, and the square root is 20, and raise it to the third power, so it's going to be 8,000. All right, so we can scratch the 3 zeros. All right, so what's 50 divided by 8? So what's that? So we can, this is both even, so 25 and 4. So this comes out to be 400 minus, right, what's 25 divided by 4? 6, 24, 10, so it's a 2, 8, 5, 20, and 0. So this is 6.25, which is going to give us 393.75, and which is the answer that we are looking for here. Right? So this is the amount of salt you're going to have when the tank is full. All right, that's it. I hope that this was clear.